My name is Mark Rümmeli. I'm a research professor. I'm based mostly in material science, although originally I studied with physics and computer science. I have a mixed background. I was born in Malawi in Africa, and my father was Swiss and my mother was British, so I have a British-Swiss passport, and I've had the good fortune of living all around the world in many places. In South America, apart from Africa, North America, North Africa, different parts of Europe and East Asia. And most recently I've moved to the Czech Republic, to Ostrava, to VŠB, where I'm setting up a new project, the EBEAM project, which is an ERA project funded from the European Horizon 2020 program. And this gives me the opportunity to start work that I've been planning for many years and haven't had the opportunity, where I can work with so-called scanning electron microscopes and use electron beams as a way to drive 3D printing with very high precision, so towards the nanoscale and potentially even beyond that towards the atomic scale. Within the use of scanning electron microscopes, where you basically have an electron beam, which is a stream of charged electrons or particles that get fired onto a sample, this beam can then scan to form pictures. Typically that's how we use such a machine, where we can get these beautiful images of particles and structures. We are now wanting to use the interface, so exactly where the electron beam touches the surface of a material, that we can drive a chemical reaction and produce something or manufacture, fabricate a material only where the beam touches the surface. And these beams have very narrow diameters, very small, and if we keep scanning, you could think like a 3D printer, where we use the electron beam to 3D print materials of different types. There was a famous physicist, Richard Feynman, from the University of California, a fair number of years ago, decades ago. He got the Nobel Prize, and he wrote a paper in a university magazine where he called it "There's Plenty of Room at the Bottom." And he predicted and dreamed of us being able to work down towards the atomic scale, where the physical properties of materials change. These days we know that as nanotechnology, whereas we get very, very small, the properties of materials can be modified and adjusted and tailored. But to fabricate that in an easy manner, where we're not wasteful, and where we can program it, is still a challenge. And this project aims to be able to, in a programmable manner, provide very high precision, nanometer scale fabrication of materials. So that is the big aspect for that. Where can we use these materials? This is important. There are a number of potential applications and others that we don't know yet. We will see once we have such technology. But we can think of microchips in our phones and computers, where we have very small devices, transistors, many millions of them, billions of them on a chip. And these are usually fabricated in what's called a top-down process, where you have many layers and you remove material until you end up with something very small. And that's very wasteful, and we use nasty chemicals. Being able to just directly grow these transistors or devices, and maybe smaller than we currently do, ultimately at the atom scale, is something scientists and engineers dream about, and that's part of this work, is driving towards that. So microelectronics is important, biomedical applications and energy applications, and one could think of combining both of them, where you have, for example, a biomedical nanobot that can run through your bloodstream, delivering medicine or treatments in specific locations. This will also need energy to do that, and so you might have these tiny batteries produced also by this fabrication, where you can produce the whole robot with all the detectors and the medicines and the battery, all produced at one go from this machine. The goal is really to make an impact and produce a future here now in Ostrava. For me, as a child, I used to enjoy watching Star Trek, and there were many things I enjoyed with sci-fi and futuristic ideas. And there was this machine, a so-called replicator, where a user would come and demand with their voice, "Please make me a cup of coffee," or "Please make me a tool." And this kind of 3D printing is really moving towards that, where we have machines where we can just command them to produce anything that we want. And this is the goal now, to start making such machines on command manufacturing here in Ostrava. Science, certainly when I was younger, could be differentiated from industry, at least from when I finished university. Colleagues who went to get jobs in industry would receive training, and they would have continuous training and upgrade their skills over time. In science, in particular research science, you kind of have to fumble and find your way alone. And I think academia is beginning to change, and I see that as very important, that we have a structure to support younger researchers, to understand the different processes involved, to provide the training for them, not only to stay in academia, but ultimately academia produces people for the real world. So if they're able to have these skills and knowledge bases that they can transfer and take outside of academia, I think that's very important. It isn't just doing experiments. Experiments is very important, and having people who enjoy the joy of discovery, which I do, which is one of my passions in science. There's also these other aspects in being able to bring in money, being able to manage that money for equipment and for the research, being able to pay for people. So this is really like running a business in many ways, and these kind of skills young people need to have. So I really hope to be able to contribute in some small way towards that. Ostrava is an interesting choice, and I can understand why people might wonder, why would I come to Ostrava? So there are a number of reasons. One, I feel European in my heart, and I am very pro the European Union and feel part of that, and the Czech Republic is part of that. I also have a long-standing experience with Ostrava and VŠB Technical University, spanning back to 15 years or more. And this started with the director from one of the nanotechnology institutes here when she was at a conference at ETH in Zurich, funded by the European Union, which I attended, and was trying to bring people together. And I met her, and she invited me to come to Ostrava, to VŠB, and I came to visit because I was working in Dresden at the time, so it was easy to drive over and visit. And she introduced me to a lady, Professor Grażyna Martinkova-Simha, who's actually now the director of the Nanotechnology Institute. And we got on very well. We started developing projects and collaborations that have just continued for more than a decade now. And maybe 4 or 5 years ago, she introduced me to another director, Lucia Obalova, who's the director of the Institute of Environmental Technology, where the EBEAM chair is held. And we got on very well together. We've collaborated now for coming on 5 years, and she's always given me support and space to develop my ideas around research, not just scientific research, but I feel it's very supportive. And so I've kind of got to know VŠB well over the years, and so it was a very interesting proposition when she suggested to me that we apply together to the European Union for this project. So yes, I'm excited to see where things go. And I can see also Ostrava is changing. Its history was much more with mining, coal mining and steel, and for very obvious reasons it's changing, and I feel the place is in transition, and that's always exciting to be a part and to live and see the changes and transition coming. And I think VŠB is moving towards high tech. I feel Ostrava is moving also towards tech, and we see that with new factories being developed here. So to be in some tiny way a part of that is also very nice. And there's another part of Ostrava and the Czech Republic that I and my family like. I have a wife and a young son. Is that it's very easy to access nature outside. We can get in a car or take a tram. The public transport is fantastic here. We can go and have picnics, we can go on hikes. The zoo is really fabulous. So this is not something I had in my past when I was in East Asia. We came from cities with many millions of people. The city I moved to from China had 11 million people in the city. And so this is a very nice change for us, especially with a young family, that we have this amazing access to nature. We are still very much in the early stages of assembling a team here. So we have some people who contribute part-time towards the administrative side of the project. I have an assistant. And in terms of researchers, we're waiting for the first researcher to come on the 1st of June this year. So in a few weeks she will be coming, and then a few other postdocs and PhD students will be joining in the second part of 2024. And we are also in the process of having our laboratories and offices developed. So one of the nice things is that VŠB has been very supportive in providing a lot of floor space and development of new laboratories and funding those facilities, and that takes time to get that done. But we will be ready. We have temporary offices that will be ready by the end of this month. And by the end of this year, we will have all our facilities and many of the equipment that we need available. So that's great. That's exciting to build something in terms of facilities as well. When I was very young, I'd intended on being a pilot. I dreamed of being a jet pilot. And I'm colorblind, so when I found that out, I realized being a pilot wasn't really a possibility. And my father had been an engineer, and I was always interested in that kind of work. So I had applied to a number of universities when finishing school to study engineering. And by chance, one of the universities wrote back and said, actually, if you would like, you can join one of these physics and computer science programs. And in an instant, I knew I wanted to do that. I called them immediately and said, please sign me up. And I've never regretted that. I joined, actually, it was quite a small class, as classes go. And the two senior professors were very dedicated. They were wonderful teachers. And I've never looked back on that. And through them, and through that university and the opportunities that the people afforded me there, I got into fundamental research, and I've really enjoyed that and still enjoy working in the laboratory with hands-on experimentation. In the past, I've worked for a number of academic institutions, from universities to research institutes, and even outside of research. So when I finished my PhD, I actually moved to the Caribbean, and I worked with a medical university, helping them develop a hybrid online teaching platform. So this was really going back in time, where the internet and browsers was a new thing, and AOL, America Online, had just come out. And the university had a hybrid teaching platform where they taught face-to-face with students, and the rest of the time they taught by distance, but this was through regular post mail and books, and very slow. And I said, hey guys, we need to do this with the internet. So they were very gracious and gave me funding and a team, and we developed an online teaching platform for them. But later on, I had the urge to get back into fundamental research. So I then joined the German Aerospace in Berlin, in Germany, where we worked on a project with NASA, developing parts for a telescope that was going to fit into the back of a 747 aeroplane. So that was really a great time working with them. And then later I joined the Leibniz Institute in Dresden in Germany, where it came to a point where I can remember the head of department saying, when my immediate boss left, he turned to me and said, Mark, it's time for you to set up my own group. And I learned a lot from that experience, just diving in with no training to set up a group, and built that. And then later I went to South Korea, to a very good university there, and also Institute of Basic Sciences, and building up a team there and facilities and electron microscopy facilities. And from there I then moved to China, and I still have running groups in China at the moment. And of course you have many collaborations in between, including this long-standing VŠB collaboration. And yeah, I had also a position with the Polish Academy of Sciences. And yeah, when this EBEAM project came through, I was very happy to return to Europe and to again start something new. So a lot of my past experience has been building laboratories from the bottom up, and so I have a lot of experience now to bring to that in setting up facilities, managing it, building a team, and keeping the knowledge within the team. So it takes a fair amount of work, but it's also very exciting and very fulfilling. There are differences around the world in how people conduct science, and even within different institutions, research institutes and different universities, each have their own research culture and the way that they manage things. East Asia, so South Korea and China, really is very productive, and they work with very high numbers of people and researchers, more than we have in the West, at least from my North American and European experience. So that's kind of helpful sometimes when you have very large numbers of people available. I think the training is probably more foundational within Europe and North America. And I also see how universities and institutes are managed vary too. And so I'm still learning how things work here at VŠB. I do see some changes. For example, how people become associate professors and full professors is quite different to maybe more Western Europe and North America, in that here it seems that people get these titles through a so-called habilitation process, and then the title is awarded from the president, and this requires quite a lot of work that did exist, for example, in Germany, and you can still get a habilitation in Germany, but there are other ways to do it through research and showing from your research publications. And these are usually titles in the West that are given to people through the university. The university has that power, and so that makes it much easier to do that. And so one of the challenges for me now is to understand how we make the system here in the Czech Republic attractive to international researchers who have the relevant experience, but maybe their position in terms of their title isn't so easily recognized. And I'm aware of the leadership within VŠB and other universities within the Czech Republic understand this problem and are looking to change that. And so I've also worked in Poland, as I mentioned to you before, with the Polish Academy of Sciences, where this system was also there, and this has changed, and I'm hoping that this will also change here, simply to be more attractive and a more even playing field for international researchers.